Okay, hello. Okay. I'm fine. I'm fine. Right, thank you very much for your question. Okay, I'm fine. All right, so now let's scan your attendance. All right, and then let's be share with you. Okay, I want to share with you the chapter 3. Okay, the chapter 3. All right, go to chapter 3. Okay, go to chapter 3, find your book, numerical. Okay, go to page chapter 3, go to page 71. Okay, today we are going to learn interpolation. We are going to learn interpolation. Okay, let's first scan, or you go to the telegram to scan the attendance. Okay, thank you very much for your attendance today. All right, I'm waiting all of you to go to the live YouTube. Okay, based on the Google form that let's we go to the Google form. Here is the Google form. I'm want to share with you. Okay, the the outcome. Okay, since I'm waiting for others. Okay, the outcome from you about the subject. Okay, about the subject. Okay, this is the response. Okay, from all of you. Let's I share with you the response. Okay, I go to the sharing. Okay, session to the Chrome tabs. Okay, here. Right. So you can see here. Okay. Most of you agree. Okay. Most of you agree that the distant learning is good. All right. And then most of you using laptop. And then you spend much time. Okay. Or most of you said that 5 to 7 hours, 3 to 5 hours per week. Okay. Thank you very much. Okay, how efficient the e-learning in the synchronized learning? Okay, same you said that very effective and moderate. Okay, moderate effective. All right. So now, which is a platform for synchronized learning? Okay, you love. I'm implementing live YouTube. Some of you love to use WebEx and then a little using Google Meet. Okay, that's why I'm using live YouTube. How about numerical subject is offering good resources? Okay, yes, very helpful, right? And then the numerical lecture is it help you? Okay, most of you said that extreme helpful and very helpful. And then how helpful in the environment, peaceful environment you at home. You said that good. Okay, some of the average, all right? So it's a good. So means that we have no problem running e-learning with the distant, okay, with the virtual, with the cybergogy environment. Are you certified with the technology and software? All right, you said that good, and some of you said excellent. How important face-to-face to you? Yes, it's important, average, good, and excellent. However, we have a COVID-19 pandemic. There is a distance, okay, between you, your family, your friends, and so on. So now, how often you communicate with me? Some of you said average, some of you said then 21.5% that good, and then below average. Come on, keep contact with me. All right, I'm always okay, answer your telegram question, okay, or your SMS, okay, WhatsApp and so on. Please keep, okay, improve your communication with me. All right, only how many percent? 3.1% said that excellent, okay, and then many, okay, 15 said that good, and then 44.6% that average. Okay, how easy you access the e-learning to get the e-material? All right, I'm very happy because you said that excellent and also good. All right, I'm trying to make sure that the e-content, e-material will help you very much. All right, for asynchronous learning, we have two types. The first is synchronized, the second is asynchronous. All right, madam. Okay, this one is I have a you scroll down the 10 attendance list, we can see if we have scanned out attendance because our app is a problematic. Sorry, madam, for the inconvenience. All right, so now let's go to the attendance. All right. Okay, we go to the attendance, let's share screen. Okay, we go to the attendance. Attendance class. Okay, now, okay, go down. Okay, go down. Now is a 42. All right, so you have okay 42 students. Okay, now, okay, and I hope will be increase because it's very important for you. We are now in chapter 3. All right, please. Okay, it's very easy to deal with the live YouTube, and I hope that you spend time okay with us. Okay, in your lecture. Come on. All right. All right, so I answering the question, okay, and then Krishan said, "Good afternoon, madam." Yes, good afternoon, Krishan. Okay, good afternoon, Krishan. All right, so now we continue to let's I share screen. I want to share with you the okay okay now. I want to share with you the what we learn now. Okay, what we learn now is an interpolation. Okay, I hope I can share with you the video. Okay, come on. We go to stop sharing and then go to the chat. E-learning. Okay, Lagrange interpolation. We go to the Lagrange interpolation. All right. Now, when we go to chapter 3, okay, when we go to chapter 3, okay, let's be focused in chapter 3 in the interpolation. Okay, when we go to this chapter 3, what we learn, okay, we're going to learn about interpolation. The meanings of interpolation, okay, is just the type of numerical analysis, all right, to estimate the new point, to get a new point in the set of data. All right, not just to estimate, you can also okay get a graph, get a function of the data given. So the use of interpolation is to perform, okay, to perform data into a function, into an equation to get a root, right? Into a graph. We want to transform a data into a graph, into a table where easy to analyze. Okay. Second, we use interpolation to find the missing data. For example, you know the value of X, but you don't know what the value of Y. You know the day, but what you don't know what the level of the rainfall, for example. So the next is to predict what happened okay, for the data for the future. All right, so you are using the observation and you are using the monitoring of the data. All right, so now this is what we learn. Okay, the first thing why we learn interpolation. Okay, come on, we are learn interpolation because okay, first we want to okay train the data. We want to transform the data to the function, to the graph, to the table. Okay, we want to find a missing data. Between a data, there is a missing data. All right, for example, there is a missing data if your data is year by year, day by day, all right, minute by minute, second by second, and so on. So you miss a second, a certain second. So you can trace when you have a graph, a function, all right. So that's why we think that interpolation is very important subject. All right. Since we deal with the data, there are two types of data. The first is a uniform data. The second is a non-uniform. Uniform data means that every day, every 2 days, every 4 days. All right. So there is uniform. Non-uniform data, okay, the data is sometimes, okay, they send you every month, after that every year, maybe every 2 years. So the data is not uniform. So what is a interpolation? All right. What is the interpolation? All right. The interpolation. Okay, let's be focused. Okay. The types of interpolation. There are two types. Okay, for the early stage. The first is a linear interpolation. The second is a Lagrange interpolation. All right. This is for non-uniform data. Okay, and then the third is a Newton divided different interpolation. Newton divided different interpolation. This is a non-uniform data. For uniform data, there are two types. Okay, interpolation that you learn. The first is Newton forward different interpolation. The second is a Newton backward different interpolation. Right? So you go to the book. Okay, every what I mentioned here. All right, you can go to the books. Okay, go to the books. Okay, you have how many types of interpolation? Okay, there are linear interpolation, Lagrange interpolation, Newton divided different interpolation, and then Newton forward, Newton backward. So you learn 5 types of the interpolation. Okay, 3 depend on the non-uniform data. The 2 others is a uniform data, right? So you know what is different between uniform and non-uniform data. All right, so now let's we continue. Let's we focus. The process, okay, when you have a data. When you have a data, you can transform the data to the function. And then you can find the data missing. Towards the end, you can do the observation of data, monitoring data, and then predict, okay, what happened to the data. All right, so this is a type of the process. Okay, the first is what? Come on. Okay, you transform the data to the equation. From the equation, from the function, you can find the missing data, and then you can do the observation. All right. Sometimes we go for the opposite direction. All right. So now Lagrange interpolation. Okay, there are 2 types. The first is a linear interpolation. The second is a non-linear interpolation. Okay, what is a non-linear interpolation? That is my question. Linear, you know, okay, where the data in the linear, you can say that y equal to mx plus c. Non-linear, okay, the data is not linear. For example, non-exponent, sinus, cosinus, tangent, trigonometry, that is not non-linear interpolation. Quadratic, cubic, and so on. All right, so now my focus today is 2. The first is a linear interpolation. The second is a Lagrange interpolation. We try to finish 2. All right. So let's be focused. Okay, what is the linear interpolation? All right. The linear interpolation, we assume the data is a straight line. Okay, it's a linear. It's a y equal to mx plus c. Okay. All right. Okay, you go here, you look, you see, you still remember the formulation. All right. Okay, go the formulation. Okay, so this is a equation for linear interpolation. Okay, let's remember y equal to mx plus c. All right, so this is y equal to mx plus c. All right, y equal to mx plus c. All right, okay, you look. All right. So since you know the y equal to mx plus c, okay, we can look. Okay, we can look here. Okay, the equation. Okay, you can see the equation. Okay, here. All right. So now, okay, you can also write, okay, y equal to mx plus c between x and x naught, y naught, and x1, y1. Okay, there are 2 points here, x naught, y naught, and x1, y1. All right. And then based on the data, you can focus to grid. Okay. M is a y1 minus y naught, x1 minus x naught, x minus x naught equal to y naught. Okay, this is a common equation when you do the linear function for 2 points. Okay, for 2 points. What is the point? X naught, y naught here. and then x1, y1. So you can know the gradient, and then the graph go through the uh, y-axis. Okay, y-axis. All right. So this is a function to represent the data. How many data? We have two data, x naught, y naught, and x1, y1. All right. So you can draw in the table form. Okay, you can draw in the table form like this. Okay, very easy. So you know what is I? I is a data, the location of data. X naught, okay, the data at x axis, and y naught is a data at the y axis. All right. So this is how we transform data to the graph, or graph to the data, and then data to the equation. So now, based on the linear interpolation above, all right, you can create a function, okay, from the table or from the data, from the graph, okay, from the graph, all right. So this is a formula that you can remember again, okay, come on. Y equal to y minus y naught, x minus x naught, x minus x naught plus y naught. So now, this is a question that I want you to answer. The first question, how to find the function, okay, using linear interpolation. How you want to represent the data to linear form, okay, linear function. Second, how to find the value of y when x is given by 2.0. All right, from the table, you know that the data is uniform or non-uniform. Come on. I want to share with you which is uniform and which is not uniform. All right. So, any question? My question here. Okay, you can't hear me? Why? Okay, you can't hear me. Okay, I'm using the 100%. Okay, and then this one also I'm using the mic. I hope you can hear me. All right. Okay. I'm using mic. Okay. So I think you can hear me. All right. So now my question is, is the data, is the data uniform or non-uniform? Okay, please. Yes, because I'm using mine, so I hope you can hear me. All right. So, is the data uniform or non-uniform? My question. Can you answer my question? All right. Can you answer my question? Is the data uniform or non-uniform? You can see the data here, X 1.0, 1.4, 1.6, 2.0. Is a uniform or not uniform? Come on, I want to have, yes, this is not uniform. If not uniform, you can apply linear, Lagrange, and Newton divided. All right, please remember, you can solve this non-linear using three methods: linear, Lagrange, and Newton divided. All right, very good. All right, the answer is none. Thank you. All right, so now we continue. Okay, since now, your function is to find the linear interpolation. The second is you need to find a missing data. What is the missing data? What is WY when x equal to 2? So now this is a linear interpolation, or we call as P1x, or degree 1 Lagrange interpolation. So please remember the formula of the Lagrange interpolation degree 1 or linear interpolation is y1 minus y naught, x1 minus x naught, x minus x naught plus y naught. Please remember, all right? We get from the formula of linear system for go through line, y equal to mx plus c. Very good. So now, this is you need to remember the formula. You have x naught, you have x1, you have y naught, you have y1. All right. So you use 1.4, and 1.6 as your point. Okay, you can choose any 2 point. Okay, is available for you. So in this case, you choose 1.4 and 1.6. All right. X is y1 is 0.47 and y naught is 0.663365. All right. x minus x naught 1.4, and then y naught 0.3365. All right, you can choose any 2 point because linear interpolation involves 2 point only, 2 point only. All right, very good. Now we go to the function that you create of the linear interpolation based on the two data. What is the data? Okay, in our example, we are using two data. What's that? Is a S0, S1, and S2. S1 and S2. You can use S0 and S1. It depends on you. All right. So the important is you create a linear system. Y equal to mx plus c. P1x, polynomial degree 1 is equal to 0.6675 x minus 1.4 plus 0.3365. All right, y equal to mx plus c. So this is a function that you are going to create. Y equal to mx plus c. You can create this based on the formula straight line through the 2 point. Okay, so now my question, I stop here. My question here, all right. Can we choose one as, we can choose, The question here, yes, you can choose x0 and x1. Beside you are using x1 and x2, all right. So you can use x0 and x1, Now, we go to the my question here, all right. So my question here is, how do you know? Do you know how to transform this equation to y equal to mx plus c? Mx plus c. How you transform this equation? The equation that I send to you now is y equal to 0.6675 x minus 1.4 plus 0.663365 to the linear system y equal to mx plus c. The answer is yes. When you said yes, means that you are success. You are success to transform the linear interpolation to the linear form y equal to mx plus c. You can get the m is 0.6675, the c is 0.3365 minus 0.6675 times 1.4. All right. So this is the way how you transform the linear interpolation to the linear system y equal to mx plus c. Very good. So now, we focus to the we are focused to the second question, how to find the missing, the missing data. The missing data here is when x equal to 2, what is the value for y? So we know already, the function for linear interpolation. Just fit in. When x equal to 2, you put 0.6675 times 2 minus 1.4 plus 0.3365. You will get y3. You will get the value y3 is a real number. Maybe I can ask you a question. How to find y if x equal to 1.5 is somewhere between 1.4 and 1.6. Where is 1.5? Is between 1.4 and 1.6. So I drag this table to below because I want to use this table to find what is the value of y when x is 1.5. Or when x equal to 2, what is the value of y? So you press your calculator, you can get y3. All right, so now before we go straight, what is the value for y3? Can you find for me y3? Come on, find for me y3 by using the linear interpolation here. All right, find the y3 here. All right. Come on, find y3. What's the value for y3 when you use your calculator straightforward? What is a y3? When x equal to 2. All right, what is a y3? Press your calculator. Please give me the answer, the value of y3. All right, so you are now finding a missing, okay, a missing data. All right, okay, before I'm waiting for you to get y3, okay, P. Ravan said that is 1.5 minus 1.4. Okay, 1.5 minus 1.4 in our case is a x naught minus x1, kan? X minus x naught, x minus x naught, all right, S naught minus S1. All right, so you can choose 1.4 minus 1.6. Yeah, 1.4 minus 1.6. Follow the formula. Can I get what is a y3? Can I get what is the value for y3? Okay, can I get the value for y3? I'm waiting. Before that, I want to share with you some notes I already sent to the I sent already to the e-learning, okay, to the e-learning. All right, so this is the value. Okay, I view Zoom. I go to Zoom to 100%. Okay, it's more smaller. All right, so in this case, formula, okay, x minus x naught, x1 minus x naught. x1 is a 1.6 minus x naught 1.4. So you can use these two data. 1.6 minus 1.4. Right, be careful because this is not involve absolute value. So find me y3. Okay, find me y3. Okay, let's we go who are getting the value y3. Okay, y3 is a 7.37, and then also Rifat said also 3.737. Thank you very much. All right, very good. Okay. Now, let's we continue to find what is the value of y when x equal to 1.5. So the same, okay, the same process, okay, you are using the same process. Okay, what is the process? Okay, you are using the same process. You put x 1.5, formula 0.6675. Okay, 1.5x minus, okay, 4 minus 1.4, all right, this one, plus 0.3365. Okay, this one, x minus x naught, okay, x minus x naught. X naught u is 1.4. Okay, please correct this one, 1.4. You can get 0.4033. All right, so you will get 4033. All right, so this is the value. Okay, this is the value that you get from the calculator. Okay, you need to press your calculator. So my question here, okay, my question here is okay, if I okay, I continue. This is my question. All right, my question here, you can see. All right, I share screen again. Okay, I go to the Lagrange interpolation before. This is my question. Okay, what is the question? My question here, okay, after you get the value of P1 1.5, okay, after you insert the formula of the linear interpolation, all right, my question is here. How to get the error? This is my question. How to get the error? All right, so the error here is an absolute error. Okay, is absolute error. The absolute error to means that always positive. The value is always positive. All right, the value is always positive. This is my question. How to get the error? So this is my question. Okay, the error here is a difference between the linear interpolation and the data given. Okay, data is an exact solution. All right, data is an exact solution. The function you create based on the linear interpolation is an approximation solution. So they said that the exact solution, the data given is a ln, is a ln function, is a ln, means that the table given here, all right, the table given here is a ln function, right? So now my question is how to find the error. So in this case, you minus, okay, ln 1.5, you can press your calculator, and then P1 1.5 is 4033. So from the table, okay, based on the 4 decimal places, all right, ln 1.5 is ln 1.5 is can go to here, okay, 0.4055, and then P1 1.5 is 0.433. All right, so this is a formulation of to get absolute error is a 0.0022. It's a very small, okay, very small number. So now ln 2.0, okay, we need to press the calculator, and then you get P1 2.0 from the Lagrange interpolation, and then you can also find the error by subtract between ln and linear interpolation. All right, okay, and then put in the positive form. Yeah, put in the positive form. All right, so that is a linear interpolation. All right, again, I want to express here what is a linear interpolation. What is linear interpolation? Come on, can somebody can answer me what is a linear interpolation? Come on, somebody can answer me before I go to the Lagrange interpolation. All right. So what is a linear interpolation? Somebody can answer my question. All right. Okay. Okay. We know how to define what is the error. Error is between the approximation solution and exact solution. So what is a linear? We already done the linear interpolation. What is a linear interpolation? Please answer my question before, okay, or during my explanation on the, okay, okay, yes. What is a linear function? What is a linear function? All right, interpolation using linear interpolation using linear function, meaning that they are using only how many point? How many point? Only 2 point. You can choose any 2 point. That is a linear interpolation. It's very weak. All right, the error is not good because they are focused on the 2 point. So it's very weak. All right. So now let's continue. We focus to Lagrange interpolation. What is a Lagrange interpolation? Lagrange interpolation is a function, is a polynomial function, is a Pnx to present the non-uniform data. Okay, before this, you learn linear interpolation. All right, you know the formula y equal to mx plus c. However, in the polynomial function, we need to extend the linear interpolation to a few points. Okay, let's say S0, S1, and another point. All right. So the polynomial function is how many root? Maybe 3 root. All right. Maybe 2 root. Maybe quadratic. Maybe cubic. All right. So now what I'm doing now, I express. Make a very simple form. Or the systematic form. All right. When I extend to y1 x minus s0 and minus y0 x minus x1 plus y0 x1 minus s0 divided by a same function x0 x1 minus s0. So what I can get here is one we call is a polynomial, Lagrange, and then the other one is y0 and y1. So for quadratic interpolation, we extend to S0, S1, S2. All right, so means that, all right, there is 3 point involved to write the quadrat function, quadrat to x power 2 lah, all right. So you can get here x minus x1, x minus x2, x0 minus x1, x0 minus x2 times y0 plus x minus x0, x0 minus x2, x1 minus x0, x1 minus x2, y1 plus x minus x0, x minus x1, x2 minus x0, and then x2 minus x1, y2. You can see this pattern, okay? This is a quadrat okay, interpolation. Okay, you can see the first term is no S1, S0. The second term, there is no S1, okay, for the upper fraction. And then for the third term, there is no S2 for the upper fraction. So this is I is not equal to J for the upper divided or upper fraction of the function f2x, all right? So in general, okay, let's regenerate the Lagrange interpolation with a n degree. So there are two parts. The part is a L, what we call as a Lagrange polynomial, is a x minus x naught, s1 minus s1, s0, s minus s1, s2 minus s0, s2 minus s1. All right, the other one is a we can divide into two parts. L1 is a Lagrange polynomial, and then the other one is a y. Okay, is a y here is a parameter that you get from the table. So what is L? L is a multiplication between x minus xj, okay, xj minus si minus xj, where I is not equal to j, and up to n, and j is equal to 0. So means that when you do the polynomial Lagrange, okay, I is not equal to j, right? So the function that you generate for n degree of polynomial, okay, interpolation is s1 y1 plus l1 y L0 y0 plus L1 y1 plus L2 y2 plus, okay, Ln minus 1 yn minus 1 plus Ln yn. Very simple, but you need to find L. L is a polynomial Lagrange, okay, where there is a multiplication of the s1, okay, s2 and s0. All right, so now since you are quite familiar with this formula, okay, familiar with the Lagrange interpolation, it's very simple. All right, S0, okay, y0 plus L1 y1 plus L2 y2 plus L3 y3 and so on. L is multiplication xi minus xj divided by x. Okay, the multiplication is x minus xj, come on, and then divided by si minus sj, where I is not equal to j, so this is no. All right, so now let's we go to this question. Okay, this question is very simple. Okay, very simple. What is the question about? Okay, the question is, come on, we go to the question. Okay, where is the question? Okay, come on, we go to the question. P2, okay, Lagrange interpolation. All right, where is the question? Okay, this one is your answer. Okay. Okay, so now let's we go to the answer. Okay, I stop sharing. Okay, let's we go to the question. Okay, I continue. Okay, to the PDF file. Let me go to the PDF file. All right, the question is here. All right, the question is okay. The question is, you are given. Okay, you are given, okay, the data S0, S1, S2, S3. S0, S1, S2, S3. You have three grid. You have three grid, right? When you start from S0. And then you have Y0, Y1, Y2, and Y3. All right, you have three data for Y. So now the question is find the Lagrange interpolation, right? And then because why? Because the data is a uniform, and then the n is a 3. N is a start from 0, 1, 2, 3. Okay, the data is a 3. And then when you success get the function of linear interpolation, verify the function is certified the data given. Verify the function which is certified to the data given. Okay, when you know that the Lagrange is certified the data is here given. So the next is find the missing data. The missing data, what the value of the Lagrange interpolation when x equal to 2? what is the value of Lagrange interpolation when x equal to 4? So means that there is a missing data here. Okay, when x equal to 2, we don't know what is the value of y. Okay, when x equal to 4, we don't know what is the value of y. All right, so this is a 3 question that we want to answer. All right, so now, okay, let's we go to the screen, okay, sharing. We go to the video Lagrange interpolation. All right, so now let's we continue to the okay, answer. Okay, I'm already prepared. Where is the answer? All right. Okay, this is a Lagrange interpolation. Okay. All right. So now let's move to the answer. We know that n is equal to 3. All right. We know that when we have 3 data, we have L0, Y0 plus L1, Y1 plus L2, Y2 plus L3, Y3. We know that Y0 is 4, Y1 is -1, Y2 is -2, Y3 is 8. We know already. But then we don't know what is L0. So we don't know L0, you need to use the formula, okay, for 3 data, x minus x1, x minus x2, x minus x3, divided by, which is not involved, okay, S0, okay, S0 minus S1, S0 minus S2, S0 minus S3. So I is not equal to J, okay, X is not equal to S0 for the upper, okay, fractional. And then let's we insert the value. X1 is a 0, X2 is a 1, and X3 is a 3. All right, and then S0 is -1. So put inside, so you will get the value. All right, now L0 is a 1/8 x, x minus 1, x minus 3. So to get Pn equal to 3, you need to have okay, the degree of your function is 3. X times x times x is a x power 3. All right, so this is a way how to get the polynomial Lagrange L0. Okay, L0. Okay, the function should be upper x is not equal to x0. All right. So now Lagrange 2. Okay, polynomial Lagrange 2. All right, the formula is x minus x0, x minus x2, x minus x3. So you can see here at the above, okay, L1, there is no x minus x1. There is no x minus x1, all right? But the below is a s1 minus s0. You follow what you write above. S1 minus s2, s1 minus s3. So insert the value. X minus x0, x0 is a -1, x minus 1, x minus 3 divided by x1 is a 0 plus 1, 0 minus 1, 0 minus 3. So you can see here x times x is x power 3. So means that you can get 1/3 x plus 1, x minus 1, x minus 3. So it's a x power 3. Okay, how about Lagrange polynomial? Okay, polynomial Lagrange L2. So the above, you no need, you not minus between x minus x2. Okay, there is no function x minus x2. You can get x minus x0, x minus x1, and x minus x3 only. There is no x minus x2, all right? Divided by x2 minus x0, x2 minus x1, and x2 minus x3. Be careful, all right? So please insert the value. You know what is x0, you know what is x1, you know what is x2, you know what is x3, all right? So be careful when you do the subtraction and multiplication. However, you get 1/x power 3 here, x power 3, yeah, -1/4, x plus 1, xs minus 3. Okay, now my question, how to get L3? Okay, how to get L3? What is the insight in your mind? What is the terms you insight in your mind? All right. Okay, how to get L3? You know the strategy to get L0, L1, L2, L3 now. What is a strategy in your mind? All right, when you find the Lagrange polynomial Lagrange, okay, how to get L3? This is my question. How to get L3? All right. Okay, my question, how to get L3? All right, I'm waiting for you. How to get L3? Okay. Okay, to get L3, okay, come on. Right, you need to, okay, we go to the L3, okay. You minus x minus s naught, x minus s1, x minus s2. You no need to minus x minus s3. Okay, I is not equal to j. J is a 3. All right. So this one s3 minus s naught, s3 minus s2, and s3 minus s1. All right. So be careful because okay, you need to find the value of S0, S1, S2, okay, which is come from the table. So this is critical of the Lagrange interpolation. You need to do the summation of Li, all right, where I is not equal to j, all right, I is not equal to j. You can get 1 over 24 x power 3, all right, at the solution. So now P3, okay, set in your mind, what is a P3? Okay, P3 is a L0 times X0, L1 times, okay, Y1, L2 times Y2, and L3 times Y3, where you can get from the table. Okay, L0, L1, LU, L3, and L2 is a function. So you put the function L0 from the previous step times Y0 is equal to 4. All right, is equal to 4. And then next, okay, L1, all right, times -1. And then L2 is you get from the previous step, L2 is a function times -2. All right, plus L3 is 1 over 24, x plus 1, x minus 1 times 8. All right, times 8. So this is a process that you need to fulfill. So what is your last answer is the following. All function is x power 3, okay, because n is a 3. N is a 3. All right, so since you are success to get the Lagrange interpolation degree 3, you can answer many things. You can answer the missing data. You can answer, all right, the trend. Okay, you can draw the graph from the trend data. Okay, you can draw. And then the second is you can verify your function that you get from the Lagrange interpolation can be well suited to the data given. Okay, data in the graph. So when you apply P3 -1, when x equal to -1, you will get 4, which is equivalent to the data given. When you apply x equal to 0, and then you go to the P3 PT30 from the table, from the equation, okay, you can see that all the equation is similar to the yi, the data given, all right? So it shows that you already verified the function of Lagrange polynomial that you get from the interpolation, Lagrange polynomial Lagrange interpolation is well suited with the data. So now you can go to the third step to get a missing data when x equal to 2. So you use the Lagrange interpolation, you replace when x equal to 2, all right, what happened to the value of P32? So you replace, okay, when x equal to 2, you go to the previous step, the formula, the function of Lagrange interpolation, you can get the missing data is 1. Okay, the missing data of y is 1. Now you go to the missing data when x equal to 4. Where is x equal to 4? Is upper, is above of the data given. what happened to y? You can just use the polynomial degree 3 of the Lagrange. Okay, you can apply, then you can get. So now, from whatever you learn here, okay, you know how to find a missing data after you generate the function of Lagrange interpolation. You know how to create a function because, okay, because what? Because you are already applying the Lagrange interpolation where the formula is based on the Lagrange polynomial and then times the y naught, y1, y2, y3 is given in the data, all right, in the table. All right, so this is a 3 point that you learn when we give you a data. All right, again, I said to you, you can find the function of the Lagrange interpolation, degree n, and then you can find the graph from the function, and then you can find the missing data, all right, in the table or the next, okay, the future data, for example. Okay, so this is what we learned, all right, today. So, and my question now, how to get L3? I know, yeah, how to get L3? Okay, you need to do the subtraction Li. I is not equal to J, all right? I is not equal to J. If the data is L naught, so the upper divided, okay, you don't need to do X minus S naught. No, okay. The second L1, you no need to write X minus S1 at the above part. And then the L2, all right, you no need to write X minus S2 at the fractional, okay, function. And then you no need to write X minus S3 for L3, all right? So this is a function. So now, my question, okay, why we learn, okay, interpolation, why we learn Lagrange interpolation. So this is my question, why we learn Lagrange interpolation. This is my question, yeah, all right. So come on, can you answer my question? Okay, I want to make a conclusion today after I'm teaching you linear interpolation, polynomial Lagrange L, Lagrange interpolation, summation Liyi. All right. So why we learn Lagrange interpolation? Come on, can somebody can answer me? Why we learn chapter 3, Lagrange interpolation? Can you provide me some answer? All right. Okay. Your attendance now is achieved 60. I want you to have a, I think there is a good connection using using the live streaming, because some of your friends said that 65% love live streaming, easy to access. I know you have a good bandwidth. However, some of your friend is not good. So maybe I can change to the WebEx or Zoom. Okay, WebEx or Zoom. Any answer from you? I'm waiting. Any answer why we learn chapter 3? Why we learn Lagrange interpolation? Any answer? Mm-hmm. I'm waiting. Okay, since I'm waiting, okay, I'm setting one, okay, for you now. Okay, I want to wait the answer from you. Come on. Mm-hmm. Why we learn chapter 3? Okay, come on. I'm waiting. All right. Very good. Very good. Very good. Very good. All right. Let's we go to Kahoot. Okay, let's we go to Kahoot. All right. Go to your Telegram. Go to your Telegram. All right. Okay, you can see here. Okay, you can see here. Main jawab je kamu eh. Alright. Penat saya buat soalan. Okay, 50% correct. Why Dolittle not from others method? Because Dolittle is a full matrices. Okay, Dolittle is a full matrices. Crowd can solve using full matrices. Alright, and then crowd. Okay, you can see the diagonal for upper is equal to 1. Dolittle is lower matrices is equal to diagonal is equal to 1. Which method is not suitable to solve full matrices? Okay, the matrix not to solve for full matrices is a Thomas. All right, and then Kolesky. Okay, Kolesky can solve full matrices, but L L symmetry is should be a symmetry. L okay times L transpose meaning that U should be upper matrices is a L transpose. The element of L and U should be similar. What is the difference between Gauss elimination and Gauss elimination with partial perverting? Okay, the difference is what? You need to divide based on A11 very big number. All right. So you need to change by row. All right. You change the row to make sure that AII or you divide with the big value. Okay, big number. LU factorization and Gauss elimination are use row elementary operation. LU factorization, which one? Use row elementary operation. Gauss elimination using the row elementary operation. LU they are not using. They are using the uh, LLA is equal to L transpose. All right. So not many correct. Okay, never mind. Okay, you have the opportunity. All right. Okay. I think you need to do some revision. All right. So thank you very much. Any question? All right. Um, I'm waiting any question from the Telegram and also from the live YouTube. Okay, live YouTube. All right. Any question? Am I have any question on chapter 1 and 2? All right. Any question on chapter 1 and chapter 2? Come on, if there is any question. All right. Okay. question, chapter 1 and chapter 2? Any question? No question? If you want to have a problem, let me know. Okay. If you have any problem, let me know. Any question? Mm-hmm. All right. I love to share with you the full report. If we can share with you the full report. Okay. Um, okay. This is a full report. 50% correct. Okay. Let's we go see all. All right. Unanswered. This is just you can see the full report. I hope I can share with you the full report. I'm not sure if I can share with you the Kahoot here. Okay. This is the answer. All right. And then let me share with you the full report. Okay. Share with you the full report. Uh-huh. How to get this one? Okay. Share with you the full report. All right. Okay. This is a full report. Okay. So the rank. Let's we go to the high rank. See all. Okay. Okay. All right. Okay. Let's we go to the highest score. The highest score is Ahmed Osama. The second highest is Muresh. The third highest is GG. GJ. Right, please bring your number. Okay, write a complete number. And then Maurat, the fourth, the fifth is Chi, and then Chiam, Rifat, Sunni, Te, Wee Sing, Jinjia. Alright, so this is the scores. Okay, this is your scores. Come on, you can go to your scores here. Okay, Bala, okay, you are here. Right, and then come on, we go to okay. So thank you very much. Okay, for your um, very good attendance for today. We can hear you. You can hear me, right? I think I'm very clear. Okay, I'm very clear. All right. So thank you very much. Any question? Okay, I'm asking. Okay, any question? Tips. Tips for test. Okay, you go to the questionnaire. The tips of test. You go to the questionnaire. I go to the questionnaire. Right. I go to the questionnaire. If I can open the form. All right. Form here. Do the revision. Okay, there is a question here. When you answer the question, okay, for example here, what is the initial value problem? Okay, how you solve the linear system using fall position method. Fall position method. Okay, how the Newton method help you okay to solve a nonlinear system of equation. Okay, fixed point iterative method. Okay, you need to know the condition of the fixed point iterative method. And then, which is need more explanation, of course, okay, a Kolesky method where upper is a L transpose, so means that element of L is equal to L transpose, okay. Okay, there is no question on Thomas, there is no question on Kolesky, they are stopped at your crowd, okay. I think Kolesky is not, okay, it's not in your syllabus for test one, all right. So now, okay, you need to press how when you use sine, cos, tangent, you need to use gradient. Okay, gradient. If you use log exponent, okay, you use degree. You need to be careful here. All right. So I share okay with you the tips. Okay, where is the tips? You go to the okay, I share with you. Okay, I already asked you to do the questionnaire for this. Okay, so this is your tips actually. All right, the do revision for test one. When you read here, you need to okay know okay where is the question. All right. Okay, please go to your questionnaire. All right, go to your questionnaire. All right. So, any question? Is there any? Is there no my name? Why there is no my name? Where is no my name? Where in the report there is your name, but you're missing. Actually, you're missing. Okay, doctor, can you click all bot because you see is need help bot? All bot. What you means by bot? Means that you want to see your answer, your result in Kahoot. I will send to the Telegram. Don't worry. Alright, so there is no question. I want to have a question from related to chapter 1 and chapter 2. Alright, make sure that you do a revision. I give already to you the questionnaire. I ask you to do the apa ni, Padlet. Okay, you send the question in the group. When you send in the question in the Padlet, you can see your friend answer and you can learn from their submission. Alright. Okay, and then mind map also is very important because why? Because you know where is your strength, where is your weaknesses. All right. There is no question. I think you can submit in the 1 hour and 50 minutes. Okay. Before this, there is another group. Very good. They submit in the 1 hour and 50 minutes on the dot. All right, I will give you a platform. All right, meet you on because your exam will be on Tuesday night. All right, so I will have opportunity to meet you on Tuesday. On Tuesday. All right. Okay. You can keep WhatsApp me, SMS me, Telegram me, call me if you have a problem. Don't quiet. And then you have a peer, okay, peer group. You have an assignment with your peer. Ask your friend if you want more explanation. You have also learning with the cybergogy, means that I send many types of file, YouTube, live, YouTube, video, and then the PDF file, okay, and then DOC file and so on. All right, don't make it okay very complex. Okay, this is very easy subject and easy to get A. The important is how fast you press your calculator that I send to your mm, questionnaire. How fast you express your calculator in 20 minutes for one question or 10 minutes for a part of question. All right? Okay. Thank you very much. Goodbye. Okay, there is no question now. Goodbye.